So Sebastian's been working at CA for 3 years in the HPC division. He's currently a software developer working on Robinhood and Phobos. He also leads the data science team to use machine learning algorithms to better understand and manage computation clusters.
Thanks, Gaël. Thanks, Guillaume. Hello to everyone. So we are here to talk about a dinosaur for Luster, Robinhood, and make a little progress report about the fourth version of Robinhood. So no news, good news, or bad news? Well, yes, good news. The last update at LAD was 2 years ago, but reassure yourselves, Robinhood is still in development, still alive by the CA and also former members of the team. And developments can be followed on GitHub and GitHub, following this link here, for instance. And also, this is not dead because we need to have it soon in production on our clusters because we need to scale up. And the third version, as Torben said earlier, is too slow to encounter our performance requirements. So, just to remind you, what is the main focus of Robinhood? Its goal is to provide efficient and easy ways to replicate and query any file system's metadata. And I accentuate the any file system because the previous versions were only specialized on Luster, and this is not the case anymore. As said in this slide here, because we have multiple reasons to build a new version of Robinhood. So comparing both third and fourth version, we need first to scale up, to be faster, to have better performances. And for this, we chose to not use anymore SQL paradigm with MariaDB, but going to a NoSQL paradigm with MongoDB, because it scales better. Also, we work on code genericity because the third version was a huge software which was specialized for Luster file systems only, and our goal is to consider a very large set of backends. So we will try to have generic tools, each tool having a lone feature and can be used using any backend available. Also, we will try to include it into Linux repositories, and having an expert system with Luster is not easy to include it, so we will better have a library with different features and applications. And last but not least here, it's about code refactoring. The third version was a heavy code, really heavy code, caused by Luster behavior evolution, and do an update of this version was complicated. Maybe you don't know, but the number of unit tests for Robinhood was incredible. The fourth version, we will start from a clean design and also why to better correspond to current file systems. So here I will present some things that were done in the past, that are currently done, and we expect for the future, of what Robinhood v4 is composed of. So Robinhood is first, as you can see in the center of the slide here, of a core library which will have the goal to communicate with different backends. So here we have a first POSIX backend, in which it will retrieve the metadata of the files that are on it, okay? And we also have a Mongo backend to store the metadata that were retrieved from the POSIX one and also query them. That's why you have an arrow with 2 directions for Mongo, but only one for POSIX, as we cannot fetch yet the metadata directly for POSIX file systems. And we have also 2 tools that were already presented in previous lab presentation. RBH Find to query and filter all the files you have on your mirrored backend using different filters as the size of the files, who made them, at which time, and also RBH Sync tool here to synchronize a backend into another, and here to retrieve all the metadata of the POSIX backend to store them in the Mongo one. In development, we had 2 new tools. that we will present a bit later. The first one is RBHL find, which consists in an overload of the RBH find to fetch files depending on some Lustre attributes. And we have also RBHFS events to retrieve events from the file system. That can be Lustre change logs, but also maybe fan notify events or other things to update the Mongo database. And also we have on the right part the Lustre backend that we can now retrieve metadata from. Also only in a read access. And on future site, we have at least a need for having an RBH report tool that will be used to retrieve some generic statistics of the file system, as how many files I got in it, maybe having some statistics grouped by user groups or projects. So if I go back in the time, back to 2020, we presented to you two main features that were developed in the past for the year 2020. The first one is the support of custom extended attributes, which means that we can attach to every entry a key value attributes, like here you can see the path, the name of the file, and also as we made for the Lustre attribute using those extended attributes, and also presenting the conversion between Robinhood file system events and YAML to easily pass the information from I got file system events, I need to enrich them with a Lustre enricher, for instance, to retrieve some statics attributes, or new Lustre attributes also, and then update them on the Mongo backend. And also, because this conversion is already developed, the fact that we need to handle a new backend only need to convert specific logs, so for instance, changelog Lustre, into file system events to be directly digested by the enricher and then the upsert into the Mongo database. So now I will talk about three features that we worked on this last year, presenting for each of one a small demonstration. Not really crazy about that, but just to show you how it works. The first one is additions to RBH find. So we added some filter options, like the size option, permissions, but also having a filter on extended attributes. And we can easily add new filters depending on what we need, what you need to fetch metadata and define data placement policies. Also, we added the sort and reverse sort options to, for instance, retrieve all the files depending on their size, the huge files first, and adding some actions as ls, fprint, fprint0, and fprint and fls. But those actions are already defined in Find, so you know what they deals with. So a small demonstration. So sorry for the size. We have to the left side here the first command on line 1, which consists in synchronizing a POSIX file system, which is the mount point of Lustre, into a Mongo database. And we can see that using RBH find, we can select all the files that were in it and sorting them by name, which with big, huge, and small, or also sorting them by size, small, big, and huge. Okay, you need to be confident of this. If you have some doubts, you can still check the ls command, the ls option here in RBH find on the right side, where we can, yes, you can see that, okay. You can list and first the files, so we have small, big, and huge that are effectively small here, yeah, the size here. And then if we sort them by size, we have the huge files first, then the big and the small. We can also do, so this was the reverse sort. We have the normal sort here, beginning with the smaller file. And then we can also sort them by name. All right. So the second point is the Lustre backend, as presented earlier when presenting the different components of Robinhood. Lustre is a file system that we use in our clusters. And so we need to store relevant information of Lustre in the Mirror backend to determine the data placement policies that we need, such as the FID, the file layout, the OST, and also HSM state, for instance. All those information are retrieved during the synchronization between the Lustre backend and the Mongo backend, and they are converted to namespace attributes, aka the custom extended attributes I talked earlier, or the entries stored in Mongo backend, the database backend. And then the need was to filter all those entries using those information. And why we needed to overload RBH find to a RBH Lustre find is because we didn't want to have some options that are dedicated to a backend into our generic tool. So here, another example. So I created a set of directories, and in each directory, some files. And I set for the 12 file of some directories an HSM attribute to archive. The same thing with the 11th file of those directories with a no release tag this time. And then I did the synchronization. Okay, so we can print the head of RBH find result. Also note that we did not use the POSIX backend anymore, but the Lustre one to effectively retrieve the Lustre attributes. And so we have some directories and files. Here we can see with the Mongo query that there is Lustre attributes in each document. So here printed in blue. So the first one, some information about Lustre here, the love, some, etc. And also below the FID, HSM state, flags, some things about the stripe. Here are no stripes because we didn't put one. And also the OST, which is the number 0 here. And if I try to use our RBH find tool overloaded for Lustre, RBH-L find, we can then use an OST filter to sort all the files that are with suffix, an even suffix. If I use the OST1 filter, I got all the odd suffixes here. Also, I can, using the FID of the file, use it in a query to retrieve it. Okay. And to finish, we got here a query using the HSM state, and we can see that for archived and no release, I got first the 12th files, and in the other, the 11th file. The last point is about Lustre changelog reader, because without it, it will be difficult to have great performances on our clusters. So, as said earlier, the only point we have to do is to convert changelog events into RBH-FS events. So we are currently on this development, and first events are processed, so I can show you some results on that. Others are, of course, following. And we are still thinking about the right moment to acknowledge the events. Why? Because we can wait that the Mongo backend is updated before acknowledge the events, but maybe just having them stored in a temporary file, in temporary YAML file, for instance, is sufficient enough, and we don't need to wait the whole upset to acknowledge some events. That's something we have currently in discussion, and we will try soon to answer it right. So, a small demonstration also. I created a null file in the Lustre mount point. I define that I need to register a client for the changelogs, and then I change the access time of old and create new. I can see using LFS changelog command on the metadata name that we have 4 different events. The 2 first events are for the modification of the access time, meaning we have a ctime event and then a close. And the 3rd and the 4th are for the creation of the new file. Okay, and if I use the RBH-FS events saying that I need to enrich it, meaning to fetch statics, attributes, and other things that are not stored in the changelog event into the mount point, checking the client cluster MDT 0000 and printing it in the standard output. I will have first here the upsert with the change of C time and A time. Then here the close event that is converted into an A time modification. Here the big one is because of the creation file, because we need to retrieve some information about the parent, in which directory it is, its name, its path, starting from the mount point, its FID, and some statics here. Not everything is written in it because it's too big. And then we have also the close event here that was translated with the A time. So then what's next? What's for the next year? First, I need to say that additionally to Lustre, we also develop a non-Lustre related backend for a European project called IOC, which have the goal to build an I/O storage software stack for European clusters, using Cortex Motor and Phobos as object store and not only as file store, meaning that we will have really a generic backend for Robinhood that can treat both file and object stores. Also, as you saw in the previous slide, the last demonstration, we will have to work on FS event deduplication to avoid having multiple events concerning the same file. Just merge them and saying that you need to retrieve the last attributes that are modified. And also, as I said, as a starting point, we will need to have RBH v4 ready for clusters. So pre-production tests will begin really soon on our systems to have Robinhood in production during 2023. Just to remind you, the repositories are available on GitHub. Here for the 5 tools that I described in this presentation, is this talk, librobinhood, RBH-Find, RBH-Find Lustre, RBH-Sync, and RBH-FS events. And reviews and codes are welcomed. Thank you.
Thank you. Any questions?
Hi. Maybe you mentioned something about it, but if I understand it correctly, Robinhood has some sort of direct hook into Lustre because it can consume the transaction logs. But do you have something similar for like BGFS or GPFS? Or do you need to use this Robinhood find?
Not yet, because we focus on what we need in our clusters, but it is possible to add a backend for GPFS or BGFS, and then use the default tools, the generic tools that we have, and if you need other filters or other options, make your overload tool, and you will be able to use it.
Another question? There is one question online, Thomas. The network?
Yeah.
Okay.
The online question will be read.
Okay, what is the largest file system in terms of number of object files that you have tested playing with before?
I can't give a correct answer to this because we didn't have a real large stress test for our version. It will be something that we will try soon. We have some synchronizations that were already made in one of our clusters, but there are some optimizations that were not taken into account, so I cannot give a correct answer for that. But you can refer to previous presentation of Robinhood v4 that were made by Sébastien Gougeaud in LAD 2019, I think, where he presents some performance metrics and maybe can answer your question.
Okay. Anyone? No one online? Okay. Thank you, Sébastien.
Thanks.